Hi everyone, let's begin. One of the important session that is factor analysis. And here is PCA principal component analysis we are going to do. And here is we can see reliability analysis, principal component analysis, exploratory factor analysis, and confirmatory factor analysis. So first, what we have to do, we have to check reliability analysis. And after that, data reduction technique, principal component analysis, we are going to run. So first we will understand what is the case, and case is data reduction. We want to reduce we want to take it into our consideration. Only those factors, those are important. So this case, an advertising firm was interested in developing a scale to measure the credibility of celebrities in public opinion so that the right celebrities could be chosen for endorsing products. So, based on extensive literature, they identified a list of 14 qualities. What are these 14 qualities? Attractive, classy, beautiful, elegant, appealing, dependable, honest, reliable, trustworthy, sincere, expert, experienced, knowledgeable, qualified. So these are 14 qualities that is we had extracted through some literature review. So which could be important for establishing the credibility of a celebrity in public opinion. So respondents were asked to rank the credibility of some popular celebrities on a scale of 1 to 5, Likert scale. So here is the data for 56 respondents are we have taken into our consideration. And though 56 is too small a sample size, but this is for a hypothetical example, we just want to demonstrate you. But you have to take as per the statistics requirement, you have to take your data, sufficient data, whatever is the requirement. So here is total 56 respondents. And EFA and CFA, I'm going to demonstrate you in my coming up videos. So today we are going to cover up only PC. And I would discuss KMO, Bartlett test of sphericity also, and then what is the relevance of both these tests. So shall we now start Jamovi? Let me open one of the file, that is relevant file. And this is factor analysis, same file I'm going to use, and results also we are going to compare with SPSS output also. And this is the file where is all the 14 parameters are visible. All the 14 parameters you can see, these are visible. And then we will go to first is descriptives. Right, descriptive, let me transfer all the variables towards the right-hand side. And then we can see what are these parameters, what is the minimum value, maximum value, as well as we can find out knowledge and quality. All 14 parameters are here. Attractive, classy, beauty, and elegance, everything it is here. So now we can say descriptives. We will try to find out no value should be 0. So nothing is 0. I mean, no missing value. Mean value is also there. Median value is also there. The most important component then we have to look forward, standard deviation. So if any quality or any, we can say any variable, it is standard deviation is 0. So that means it is useful. It is not useful. It is useless. Why I'm saying? Because maybe standard deviation means there is no deviation among the responses. So what is going on means, let's say attractiveness. Let's say one person blindly, this respondent had filled in all the questions 1, 1, 1, 1, 1. Let's say one respondent had filled for all the 14 parameters, had given the response only 1, 1 or 5, 5 or 4, 4. So that is why standard deviation is 0. Means similar, he has mapped all the we can say qualities of the celebrity. They had mapped only one single number. So we have to ideally we have to drop this particular response. So let's say I had collected how many responses I had collected. I had collected, let's say, 56. If the one respondent have done this kind of mistake, so we have to drop this. So we would have finally 55 responses, and then we have to go for analysis. So I hope descriptive statistics are clear. Then we will go to factor. Now we have to check reliability analysis. The most important, if the Cronbach alpha, it is greater than 0.7, then only this data is reliable. Otherwise, this data is not reliable. So what we have to do, we will transfer all the parameters towards all the items towards the right hand side. We can call it item, we can call it variable also, both are synonym. And when we will talk about factor, so factor is a synonym of construct. So factor analysis, this one is the reliability analysis, then we can come to the Cronbach alpha, and Cronbach alpha is 0.871. That means it is greater than 0.7. So our data is reliable. I'm sure we can say our data is reliable. And we can check this Cronbach alpha after that correlation heat map also. So this is our correlation heat map. You can see this is our correlation heat map. Means that is it is reflecting correlation in between one factor's correlation with other variables. So mean, standard deviation, each and everything we had already done, right? And Cronbach alpha if item is dropped, right? Means suppose if I am saying Cronbach alpha, now you can see, let me copy this and I will show you here. Let's say Cronbach alpha before starting this analysis. Let me put it here. Now you can see this is the heat map, and before heat map, I think we have to take into this one as right. Copy this and we are going to paste it here. So this is our Cronbach alpha, and there is written a note. You can just focus on this note. Let me bold this and I will do correct. Note, item, this one is the appealing, correlates negatively with the total scale and probably should be reverse, right? It is giving you the suggestion. If this one is item that is correlates negatively, so this total with the total scale and probably it should be reverse. So we have to reverse this. Then we come to this is the heat map. I had already said this one is the correlation. Next we come to the going back, and now we will go to factor. Reliability analysis we have already done, and Cronbach alpha is good. Now we will come to the data reduction, principal component analysis. Now we will start. So what we have to do, principal component analysis, we will transfer all the items or all, we can say all the variables towards right hand side. All 40. So I have transferred. And now we can see this one is the component loading, principal component analysis, component loading. It is showing component loading. Component loading is, you can see 0.764. This one is the loading. And if any loading, because we had already studied in the past, if any factor loading that is below 0.5, so we have to drop it. We are not taking into our consideration for the further analysis. So first we have to check Bartlett test and KMO. So let's say I want to see, this one is the Bartlett test and this is KMO. And KMO, I said what is KMO or what is, this one is Bartlett test. KMO means this is the test is a measure of how suited your data is for factor analysis. You have to check whether this data is suitable for further factor analysis or not. So if how we are going to consider it, this is statistics that indicates the proportion of variance in your variables that might be caused by underlying factors. And if the KMO value, it is in between 0 to 1, means close to 1 indicates that factor analysis is useful with data. But if the value is less than 0.5, if this value is less than 0.5, so then results of the factor analysis may not be useful. Correct. So this is the role of the KMO. But when we come to Bartlett test of sphericity, so this tests the hypothesis that correlation matrix is an identity matrix, which would indicate that your variable are unrelated and therefore not suitable for factor analysis. So how we have to put the measurement? So small values that is less than 0.05 of the significance level indicate that a factor analysis may be useful with your data. So null hypothesis, what we had created, correlation matrix is an identity matrix, right? And alternate correlation matrix is not an identity matrix. So what is in our case? We will go back to Bartlett test. And you can see here, let me copy this and I am going to paste it here, right? Here is, now you can see, here is p-value that is 0.001. So it means our null hypothesis, it is rejected and alternate hypothesis is accepted. So means we can say correlation matrix is not an identity matrix. So it means what? So it is saying which would indicate that your variables are unrelated and therefore not suitable for factor analysis when your hypothesis that correlation matrix is an identity matrix. So means we can say our null hypothesis is not accepted. So means we can say our data is right. Your variables are related and we can go for further factor analysis. So I hope this KMO and Bartlett test you can understand. Now we will go for this, the parallel analysis. You can see now we will go for the based on the eigen value. But before that, based on the eigen value, let me put it off, right? What first we have to check the scree plot. Scree plot, what it is saying? Scree plot means on the y-axis you can say eigenvalue. On the x-axis we can say components. These are all are my 40 components. Correct. So what we have to do, it is based on the eigenvalue, right? So based on the eigenvalue, but where is the dotted line? So means it is saying when the only four on the basis of eigenvalue, only four components or we can say four constructs or four, these are the four factors only we are using for the analysis. So let's go there and we can find out. Let me initial eigenvalues we have to check. So these are the initial eigenvalues you can see. So if we have to see initial eigenvalues, 5 point eigenvalue that should be below 5. If there's the above 5, then that is we are not taking into our consideration, or below 1, that is also not we are taking into our consideration. But some statisticians are saying if that is below 1, right, we are not taking into our consideration, and if the above 10, that is also not taking into our consideration. So we will see here the four components why it's coming, right, why we are taking into consideration. Fourth one is factor, you can see that is nearby 1, 0.95. So that is why it is taking into our consideration. 1.7, that is also we can take into our consideration. 2.4, 5.7. So four factors are we can take into our consideration. The same thing is scree plot is explaining. Right. Component correlations also we can check component correlation also, right? Component correlation, right? And here is what is it is explaining. Percentage of variance means 41%, right? This is the first component that is explaining. Second is 17%, right? And third is 12%, right? And we can see overall also, right? I will show you overall also. So component summary also, and component summary you can see here. There is the component summary. You will see here. Component statistics, you can see. So total all these three factors, 70 point, sorry, 7, this one is the 34%, 18.8%, 17.8%. So total is 70.6% is explained by these factors, right? So let me copy this and I'm going to paste it here. Then I will show you how we are going to read this. And let me paste here, right? So total 70.6%, these three factors are explaining. And now how we have to club them. Now you can see this, these are my results of SPSS. Where is the rotated component matrix? Then we are going to compare here. Then we have to give some name, because first component means first factor where is the loading is greater than 0.5, or we can say greater than 0.55. So these one, two, three, four, five items are falling in this, and we had given name is trustworthy, let's say. Second component, we can say 0.70, 0.868, and all these knowledge, quality, and experience. So I had given expertise, the collective name of this factor. Then the third component is all these 1, 2, 3, 4, 5, right? This is the attractiveness I had given. So same thing, what we have to do, we are going to repeat it here. And component summary you have seen, and sort loading by, this one is the hide loading below 0.3, right? Now you can see those have loading below 0.3, 0.3. These would not be reflecting over here, right? So that means this is, we are talking about those loadings are below 0.3. These are not reflected here. And one more thing, let me explain you. This is, let's say, we will talk about fixed number, right? Fixed number is 1, right? And further is what we have to do, correlation, heat map, and all these things we have done. Now we want to give these factors. Let me show you this data. And we can see here, these are the factors, right? Factor 1. Let's say factor 1, for example, what is our factor 1? Let me check here, right? Honesty, reliability, trust, and all these things. This is the component 1, right? So component 1, right? What is reflecting? I had given name, this component 1 is trustworthy. The same thing I'm going to write here. I will write here trustworthy. Trustworthy. So this component is trustworthy. I had given this name. So now you can see trustworthy. Let me give my second variable name also. Second factor is, this is my second factor. And second factor, what name we had given over here? This is the expertise. Let's say I want to repeat it here. This is the, I want to rename it. So this is the expertise. Expertise. Right. And similarly, factor 3. Factor 3, what we have taken here is, factor 3 is attractiveness, right? Or we can take it attractiveness. So I said attractive, right? Attractiveness, or whatever is the any name, that's your choice. You are going to decide. So all these three factors I had identified. And now, once these factor data reduction means those were not playing important role. These already dropped. These already dropped here. Right. In the analysis, now you can see these already dropped. Right. These already dropped in my analysis. And those are relevant. Those have factor loading greater than 0.5. Those are only we have taken into our consideration. So probably this would be a good analysis, and I'm sure before starting any regression, you have to do first go for the factor analysis. And in the coming up video, I'm going to take covering EFA and CFA. So I hope this video would be helpful. So stay tuned and keep watching.